right, Ryan, give me something about this question. What's relevant?
Liters of ammonia.
So V volume is 48.6 liters of ammonia. I like to identify the the reactant product it's dealing with. CJ, give me something else.
10 degrees Celsius.
Okay, so that's a T for temperature, which is not really 10 degrees Celsius. It's what? 283 Kelvin. So you just added 273 to that. Something else, Ariane? And we are likely not going to use kPa, so what should we do with that? Okay, so we have V, T, and P talking about the temperature, pressure of the experiment plus the volume of the ammonia gas. Kern, what else is important? Or what's some information we need that's in the question?
44 liters of ammonia. So
We already have that here. We have volume, temperature, and pressure. Give me something else. All right, so the question is grams of nitrogen. Is this nitrogen? No, it's not. We want diatomic nitrogen because in a natural state, stable state, it'll be diatonic. And there's one more thing we need based on kind of the phrasing of this question. It should kind of indicate to you, Cole, we should write what? Somebody Cole's table, come on. We can't really talk about ammonia and nitrogen at the same time, right? So what do we need to write? Okay, so we need to write a reaction, right? Balanced chemical equation. So we have nitrogen needed to produce ammonia. So we already know ammonia is a what? A product. So that's going to be our product. What would produce ammonia? Well, we know one thing because it's told it to us. Everybody? So N2 nitrogen. So then what must be the other thing?
H2.
Hydrogen gas, because that's the only singular thing you could really add to synthesize ammonia. Balance that for me, Corbin.
You just add a 3 to the hydrogen and a 2 to the ammonia.
Looking good? Yep. All right, so now we have VCE, we have givens, and we have our question. So you should have had a moment to maybe process, how could I attempt this? So if I have all of this information up here, what stands out to you here? Shout it out. Okay, the ideal gas law starts to stand out because we don't have enough information for any of the others. So if you see P, V equals nRT, then you have to identify what piece are you missing. What piece are you missing? N, right? So N is our question, truest question from that standpoint. But what would N be standing for? What would it represent? Moles of what? Why ammonia? Because it's saying the liters are of ammonia. So I can't be talking about nitrogen if it's saying ammonia for me on one of the variables, then all the variables are representing ammonia. Got it? So this is N of ammonia that we would be solving for upon using the ideal gas law. Well, where does that get me? So before we actually problem solve, where does that get me? To moles of ammonia, okay, and then where does that lead me? Good. I hear mole to mole ratio and then grams. Okay, you guys got it. Okay. If you're already done, I would look over my foldable for a minute, just to make sure you know what you're talking about today. just looking for a number. I'm done. How many moles is that of ammonia? And what's the mole ratio I'm implementing here? 2 moles, no, sorry. 2 moles of ammonia for every 1 mole of nitrogen. 1 mole of nitrogen weighs 28-ish grams per mole. What's our total grammage here? 20.5. Just double check 6.6. Are we good here? 6.63. It was 10.00, so it should be fine. Okay, so now you're realizing the stoichiometry and ideal gas law can be either paired gas law then stoich or stoich and then gas law. It kind of depends on what's asked, but of course there are 2 methods of problem solving. We will come back to finishing up some more of these, but go ahead and get a Kahoot. Quick game of Kahoot for you. As a quick review. And I'm going to take this down in like 3 seconds. This one is good. Jake will help you. Alright, there's your code. Music is pretty up. Here. Alright, so I've got 25, 70. Give me a thumbs up when you're logged in, when you are on the computer. Give me a thumbs up when you're on the computer. Alright, I'm going to start on the board for you guys know how to do this, right? Just one more person. I'll be lying to you. 2403770. Okay, here we go. Let's see what we know. I don't know how music is, but we're gonna try. The water droplets that appear on the steamed up window are produced by. You can't see me stand up in the back, okay? Okay, good. So we're looking at steaming up a window. That means you're making liquid water, so you've got to be making water, and then basically the only thing that's going to do that is from a gaseous form, so condensation. Good. What law is represented by the picture? Six, 5, 4, 3. Ooh, okay, so it shows you what 2 variables? Pressure and volume, and you know that's the first one we kind of talked about, which was our Boyle's law. Okay, and mostly good. Next, which of these can be easily compressed? Five, 4, 3, 2. Muy bien. So easily compressed, that term easily is the one that's most important, and that would be our gases. What would happen to the pressure of a gas in a steel tank if it was heated? Three, 2. Good. Okay, so at your table, talk about why that happened. Steel tank heated up. Why does pressure increase? Go. Talk baby steps to the whole table. All right, so come back to me. 3, 2, 1. If you heat them up, they adding temperature causes increase the kinetic energy, which makes them speed up. Okay, so I'm just going to give those keywords. And if they speed up, what do? So they collide. Good. The word collision is the piece I was looking for. They collide with the container more often, hence increasing collisions increases pressure. Which of these takes the shape of the container it is in? Okay, so that is assuming the liquid is full for it to take the space the container is in. But if you put gases, if you put liquids and gases, a couple of you guys put liquids only, definitely gases are going to at least be the minimum answer. They're spread out very well to take up their container. Temperature and pressure are blank related. Three, two, one. All right, increasing temperature, like we said, speeds them up. Increased collision, so it should be a direct relationship. A gas will always occupy the total volume of a container. Yay or nay? Or sometimes, or I don't care, also are options. When is it nay? Never. Never. We just went through that example. That was like the liquid and solid, or liquid and gas example was kind of 2 questions ago. But there really, I don't think there's a sometimes there. You guys can give us an example? Not really. Gases are going to spread out. They are not attracted to each other very much. They're going to spread out always, unless some crazy, weird alien came. Always going to take up their container. What would happen to the volume of a gas in a balloon if it was heated? Alright, so whose law is that with temperature and volume? Charles's law, good. And so this is that direct relationship between those. This is assuming, of course, that we have some other variables that can possibly stay constant. But if you increase the temperature, they're going to speed up, right? They're going to want to collide with the container more, or the balloon more. What does it immediately cause the pressure? If you heat them up, what does it cause the pressure? Well, it increases, but we're not saying pressure can change, so we have to allow the balloon to expand to alleviate that pressure, and when that balloon expands, the volume is increasing to keep pressure constant, because pressure is not a variable we're changing in this sample. What is STP? You'll laugh at this one, I think. Oh, it's not that. Good job, guys. No one got confused by my throwing you out there. All right, in which state of water do the particles move about most freely? Huh? You guys don't vacuum your water? All right, good. Gases. What is there between the particles in a gas? Three, two, one. Very good. But no, if we have a gas particle, you can't say there's gas particles between the gas particles, then you're not looking at the narrow enough picture. Air is considered a gas, so we would never say air is between the gas particles, again, because you're looking between 2 individual particles. There should be nothing present there. Gay-Lussac's law describes the relationship between Three, two, one. That's basic memorization. So if you don't have it memorized, you'll have about a couple minutes after this to look over your folder if you need to. If the pressure of a gas goes up by 5, the new volume will be okay, so that was, you were looking for numbers to do math, but you had 10 seconds, so you just think of relationships. The pressure goes up by 5. Got your box of air today? Show me that box of air. Increase your pressure by 5. 1, 2, 3, 4, 5. What happened to the volume? What happened to the volume? It goes down by how many times? 5 times, right? So it's a proportion. Increasing pressure decreases volume, but if you increase pressure by 5 times, you decrease the volume by 5 times. None of the other ones made sense. Based on Boyle's law, if the volume increases from 20 to 60 liters at 60 atmospheres, the new pressure should be what? You can do it. 10 seconds. Woo, we just guessed on that last bit. Okay, so talk, I can't, that's the picture. Well, we're gonna look at the question. Show me a volume increase from 20 to 60 liters. Starts at 20, goes up by 3 times, right? To 60 liters. What was the pressure at the 20 liter mark? 60. As you expand, what happens to the pressure? It goes what? Down. It goes down and it goes down. Well, I use the same numbers all the way through, right? So what should the pressure be? Right, it started off at really high pressure, 60, and it decreased, in a 1/3 fashion. So it should be down to 20. So all those numbers were the same, so at least you maybe saw some similarities there, but you're inversely proportional. What would happen to the pressure of a gas inside a syringe if you compressed it? Muy bien. Compression increases pressure. The ideal gas constant R is? I don't know why I gave you 30 seconds for this one. I'll cut you off in 10. Five, 4, 3, 2, 1. Skipping you. All right, so good. You just have to look for the units to be correct and the numbers. 0.0821 atmosphere liters per mole K. What are the conditions at STT? All right, 3, 2, 1. Okay, and that's on the front of your foldable. 0 degrees Celsius or 273 Kelvin. Next, PV equals nRT is known as the combined gas law. Five, 4, 3, 2. All right, thank you. When using the actual gas law, volume must be in what? Three, thank you. I was going to say, you gotta know that one. Liters, very good because it matches the R constant. To convert Kelvin into Celsius. Ooh, a bunch of you guys read that too quickly. You're going from Kelvin to Celsius, so you're not going from Celsius to Kelvin. Reverse that, so subtract 273. All right, so now I'm going to save those. Now we're going to do a quick worksheet on, you know how to do SQUIC. So send me a representative from your table. Alright, this is yours to write on. You have about, let's say 10, 15 minutes to see where we are. The answer's on the bottom. This is teamwork made the dream work time. Teamwork made the dream work. Talk it out. If your buddy's not here, make sure you grab one from them. You can write on this. And yes, look how nice I was. What did I do for you? I gave you space and a valid balance equation. I did most of the work here, guys. I did most of the work. Yeah, purpose. Thank you.
I haven't heard from some people.
Actually, his buddy got one. Teamwork made the dream work. Talk it out.